Welcome to qnawire.
If the snowball has an initial downwards velocity direction, we're just going to choose downwards to be positive. So we can say that here then, to find time in the air, in order to find essentially the how far away it strikes the ground, we can say that delta y for part A equals Vy initial t plus 1/2 a sub y t squared. And we can then say that plugging in 14.0 meters, this would be equal to the initial in the y direction. So this would be 7.00 meters per second multiplied by essentially the degree of the downward slope, 40 degrees. So times sine of 40 degrees multiplied by t plus 1/2 times 9.80 meters per second squared times t squared. This is a quadratic equation, and you can use the quadratic formula. It's a bit cumbersome, so you can just use the solve function for t84, 85 in order to solve for t, and the only positive root for t would be 1.29 seconds, and then we're going to use that for the displacement in the x direction. We know that there isn't any acceleration in the x direction, so we can ignore that term completely and say that the initial x velocity times t, this would be equal to 7.00 meters per second multiplied by cosine of 40 degrees multiplied by the time of 1.29 seconds. This is going to be equal to 6.91 meters. So this would be our answer for part A. For part B now, we can sketch the x position versus we can essentially all of these. If we say x, t, this will be linear. So we'll have that shape. Let's just draw them all. This would be velocity in the x direction with respect to time. This would be, we could say y with respect to time. And then here, velocity in the y direction with respect to time. This would have somewhat of a upside down parabolic shape. So this would simply go like, rather a little bit farther, but like this. That's essentially a quick sketch. The velocity in the x direction is constant, so it'll simply be a straight line. And then straight line. There we go. And then for the y direction, it'll only get faster, but it's not starting at 0. It's starting at some value. So we can say that this would be a linear increasing slope. So these are 4 sketches for part B. Now for part C, we can say that a man is 1.9 meters tall, standing 4.0 meters from the edge of the barn. Will the snowball hit him? So we can say that here delta x is equal Vx initial t plus 1/2 a sub x t squared. Again, there isn't any acceleration, so we don't have to account for that. T is then going to be equal to delta x divided by Vx initial. This is equaling 4.0 meters divided by the initial velocity, 7.00 meters per second, times cosine of the angle 40 degrees. And t is equaling 0.746 seconds. In this time, the snowball travels downward a distance of, we can say delta y equals, again, 7.00 meters per second times sine of 40 degrees multiplied by 0.746 seconds, and then this would be plus 1/2 times 9.8 meters per second squared multiplied by 0.746 seconds quantity squared, and this is equaling 6.08 meters. So essentially we have 14.0 meters minus 6.08 meters. This is equaling 7.9 meters above the ground. Now, the man is only 1.9 meters tall, and it's 7.9 meters above the ground. So we can say that here, the snowball passes over him. This would be our final answer for part C. That is the end of the solution. Thank you for watching.